How's it going? We did our project on the chemistry of hand sanitizers. My name is Carlos Demian, and my teammates are.
Uh, Zachary Gifford.
Cameron Mitchell.
James, man. Sorry. James.
So in our exploration, we did alcohol-based hand sanitizers versus non-alcohol-based hand sanitizers, and we wanted to explore the difference between both chemically and how they had different changes. So before we discuss the non-alcohol-based hand sanitizers, let's first talk about the impacts of alcohol on the skin. When alcohol dissolves on the skin, it dissolves lipids and molecules, and that's what causes dehydration and dry skin. That's why your hands may be ashy if you use alcohol-based hand sanitizers. And alcohol-based hand sanitizers usually involve ethanol or isopropanol, and those are the two formulas for those substances. So when discussing non-alcohol based hand sanitizers, there are two substances that are generally used, and those are mandelic acid. So that's the formula for vanilla right there, and essential oils. These two substances help with the physiochemical properties of these hand sanitizers, which makes them softer for the skin and they make them less breaking, such as what the impacts of alcohol-based hand sanitizers do.
The importance of the chemical composition of these hand sanitizers, the essential oils, and that affects antimicrobial activities. Some of the conclusions from our research between the comparisons of non-alcoholic and alcoholic hand sanitizers that non-alcoholic hand sanitizers with essential oils alone are less effective, and the combination of essential oils and the vanilla, it improves the efficiency against the environmental impact on the hand sanitizer. In this case, isopropanol, is that it has the lowest CO2 emissions compared to its other alternatives.
Now we're going to get into alcohol-based hand sanitizers. The chemical composition of alcohol-based hand sanitizers. You could use aloe vera gel in alcohol-based hand sanitizers to reduce dryness, commonly found in other hand sanitizers. And thickening agents and fragrances help improve both the viscosity and aesthetics of the hand sanitizers. The effective ingredients. The World Health Organization recommends ethanol, or isopropyl mixed with hydrochloric acid or glycerol, and the alcohol concentration should be between 60 and 95%.
So now we'll discuss the mechanisms of alcohol in hand sanitizer. The alcohol functions to dissolve the lipids, denature the proteins, and essentially inactivates microorganisms. Because because the alcohol targets those specific structures in the microorganism, but not the eukaryotic structures in the human. H2O is critical in the denaturing process, and the mix with alcohol, more than 1% of H2O is what we found to be most effective. The reason water is essential in being a part of hand sanitizer is because in the presence of H2O, alcohol acts on the microbes, damaging their lipid structures and denaturing the proteins, as we discussed in the last slide. Some hand sanitizers do contain toxic ingredients, which compromise its safetiness. Overall, the main effect the toxic ingredients really have, though, is making your hands dry and ashy, and not long-term detrimental health effects.